All right. So for your first example, remember that we put our function into the calculator into y equals. We found these two perfect x-intercepts. We did synthetic division with them. When we finished synthetic, we came up with x squared plus 4 to find the remaining zeros of the function, and these are imaginary. So on the next one, how many solutions should I have? 4. I should have 4. Let's figure out where the good ones are, if there are any. All kinds of stuff in my calculator. So x to the 4th plus 8x squared minus 9. Not my table, I'm going to graph it. What do you see? Where they at? -1 and +1, right? So we're going to do synthetic. I'll write these over here, -1 and +1. So that means, what about the other two? They're imaginary. So we'll come up with some eyes. So we're going to do 1. You could have done -1 first. It doesn't matter. Across, I have 1x to the 4th, no x cubed, x squared, no x, and a -9. Bring down your 1. Times 1 is 1, plus 0 is 1, times 1 is 1, 9, 9, 9, 9, 0. Remember, you should come up with a 0 because it is a solution. You're going to take -1 and put the numbers that are on the bottom. 1, 1, 9, 9. Bring down your first one. Times 1 is -1, which gives you 0. Times -1 is 0, which gives you 9. Times -1 is -9. What does this leave you with? I'm sorry, is 0. Geez. What does it leave you with? What the last one leave you with? X squared plus 9. How do I solve it? Subtract 9 and then do what? Square root. What's the square root of 9? Remember, it's a positive and a -3. How do I deal with that negative inside? So your other solutions are plus or minus 3i. So there are your 4. All right, so I'm gonna ask one more time because it says to write it as a product of linear factors. What are your factors? I didn't do it on the first one because we were running out of time, but we'll talk about both of them. What's your first factor? X plus 1. So I'm going to write it right here. You guys don't have to if you don't want to. It's just there. What about this one? What does it cost? And then how did we come up with plus or minus 3i? Yeah, but what was our factor? What did we say equal to 0? That x squared plus 9 is your other factor. So when it asks you to write it like that. So knowing that, go back to the first one. We have a bunch of factors. What's your first factor? X plus 2. What's your second factor? What's your next one? Ooh, x minus 1 and x minus 1 is x minus 1 squared. And then how did we get this plus or minus 2i? What did we set equal to 0? X squared plus 4. There you go. All right, same thing on the next one. How many solutions should I have? We should have 3. Let's see how many we have. X to the 3rd minus 3x squared plus 7x minus 5. What do you see? Why does sometimes it look fine and then other times it's absolutely ridiculous? What do we see? +1 looks like a +1. All right, so we're going to take that 1 and put it in the box so it goes across. Perfect. Drop down your 1 times 1 is plus -3 is times 1 is plus 7x times 1x. Our remainder should be 0. We don't have any other whole ones, so all we have is x squared minus 2x plus 5. How would I figure out my other two? What are my other two? Let me ask this. What are my other two going to be? Imaginary. So there's only 2 ways we can figure out imaginary. You could do quadratic formula or completing the square. Does everybody understand? I'm going to go over completing the square, quadratic formula. I can do this one, completing the square. Remember, I told you because it's easy numbers in the front. Like if you had to take out some weird numbers, I'd probably just go ahead and do quadratic formula. So on this one, I'll move that -5 over and put a blank. What's going to fill that blank? Because I don't have to take anything out. How do I get the blank? 2 divided by 1 squared is 1. Since I didn't take anything out, 1 goes in both blanks. How do I rewrite this left side? X minus 1 squared equals -4. I know that's a tough one. How do I solve this? Because I don't need to move that 4 over. I just need to keep solving. Take the square root. There's where your imaginaries happen. So I get x minus 1 equals, what am I going to have? What's the square root of -4? Plus or minus 2i. Don't forget your I on there. And then how do I get x by itself? Put the 1 in front of the plus minus 2i. So your 3 solutions are 1 plus 2i, and 1 minus 2i. What are your factors? What are your factors? And then what did we set equal to 0? The x squared minus 2x plus 5. That's the best it'll do. More like this. X to the third minus 11x squared plus 41x minus 51. Where'd it cross? At 3. So that means, what are we going to have? 2 imaginary numbers. It's going to be exactly the same as what we just did. So we're going to put our 3 in our backwards box. And what goes across? Bring down your 1 times 3 is plus -11 is times 3 is plus 41 is times 3 is 51. So this leaves me with x squared minus 8x plus 17. That's going to be one of those factors in the end, because that's what we'll set equal to 0. How do I fix this? If there's not a number in front, the faster way to do it is by not quadratic formula, is by completing the square. If it's got numbers in front that you have to take out and they're going to make nasty fractions, quadratic formula will be better. So we're going to move that 1 over, or that 17 over. How do I fill in the blank? 8 divided by 2 is, squared is. Since I didn't take anything out, I can just throw 16 over there. Rewrite the first side. X minus 4 squared equals -1 is what causes the imaginary.
Girl.
Oh my gosh, what's going on?
I forgot to do six toys. I forgot how to. All right, so I know. So fourth period, I have been going over there and trying to reteach from the day before. Shouldn't we be doing a quiz on altitudes today, since that's what we did yesterday?
I think they did the quiz on altitudes yesterday. I set it up so they could do it with their notes instead of having to turn their notes in and not having them.
So we did not do that. They did their quiz on bisectors yesterday. And then because
The altitude quiz, I didn't give them at all. I didn't give them at all.
oh, they know that stuff.
Give it to them.
Okay, so can we do that first?
Yeah, you can do whatever you want.
And then we will, and I made them do the bisectors quizzes somewhere. I did not let them do it online because I was teaching it
Right.
and people were sitting back there working on their computer. So I thought they were cheating.
Oh. Yeah.
So I made everybody do it on paper.
Okay.
So I just don't know where it's at.
She would have it. My mom has it.
Okay.
It's all in a stack all
Okay.
together. And I told her not to give it back or anything like that, because I wasn't sure what it was.
Mr. Sink took it up yesterday.
Yes,
Yes, but
but
it
she
is-
has it.
Okay, it is not online. That's my fault.
Okay, so they just need to put it in
So
there.
can we go take
Yeah, you can put
the
it-
altitude?
Yep, it's that one. Isn't that one altitude? Yep.
It is.
I just didn't give it.
Okay. Are
And
these
then
your
this
notes?
is, yeah, they're really sloppy and I'm sorry. I don't know
That's
where the
okay.
clean sheet is.
I'm just trying to, that,
She might have
it's
the
okay. She's got.
good looking one.
That's okay. They are, they're a hot mess for period. And so, but they're doing good if I'm in there. I mean,
Okay.
like, you know what I'm
Yeah.
saying? So we're a little bit behind, but
She can catch them.
he's coming back today.
Yes.
And I will.
Said he
not-
was.
And I will not be in there tomorrow because I got an observation.
Well, they're just doing review stuff. So it's all review of this material that they've learned this week. That's
Okay.
what Tony said to do. So
Okay.
that's what I did.
Okay, I'm so sorry about
No,
that.
girl, it's okay. Don't worry about it.
This gal was in observation on me though.
Oh, there you go.
For my next job.
All right. Sorry, that's all gonna be recorded on video. What did?
She came walking in and I went.
Well, y'all saw I didn't have mine up, so she got like real close, and then I was like, I'm gonna get her. She, whatever.
Oh, she.
She don't care about-
I didn't even think about that.
No, she does. She does. She does.
She does what?
She does care, but she's not gonna care that I'm teaching without it because I'm far away from you guys. Yeah. So, and it sounds so muffled that you guys would be like, what? What? All right, we're gonna keep going. How do we solve? Square root. We have x minus 4 equals, how do I fix this? Plus or minus, you can do one I or just I. And then how do I solve? Add the 4 and it just goes right in front, whatever you're doing, it's a positive 4 right in front. So there are your solutions. Bless you. Your factors. If I had a positive 3 answer, my factor is -3. And then what we said equal to 0 over here is going to be your other factor. So x squared minus 8x plus 17. If they have anything different, it may be because they say do the linear factors. So I don't really want you to do that, but it would be x minus 4 plus I and x minus 4 minus I. But I don't like that. Okay, so I like it like this. Is everybody good?
Yeah.
Everybody else okay? All right, flip it. I don't know why y'all are so intimidated. She is really-
She was happy when she came in. It's not like she was mad.
Me? You thought I was in trouble? I didn't do anything wrong.
No, no.
I can't be in
I'm just
trouble.
saying, I know.
I'll wait
I
till-
do that a lot. Somehow I always-
And then I already told you.
What? No, I'm not talking about this in school. I just.
So these are just examples, this is not like a formula.
Yes, correct. Same thing that we've been doing this whole time. Plus A1x plus A0. Sorry, I didn't fit it all the way in there. I know, to be a polynomial with real coefficients and a sub 0 does not equal 0. Yeah, I know. Right. It just says the polynomial. We're doing rules. So this is the same thing. These two things that we filled in the blanks are the same thing that we've had. It just represents the polynomial in descending order. And then it says that last number can't be zero. So we're gonna have that last number, that just constant number on the end. The number of positive real zeros. Of f is either equal to the number of variations in the sign of f of x or less than the number by an even integer. And then the number of negative real zeros of f is either equal to the number of variations in the sign of f of negative x or less than that by an even integer. I'll explain this in the example. Okay, it's easier to look at in the example than it is anywhere else. So all they're going to ask you is determine the possible numbers, not the exact numbers, the possible numbers of positive real zeros and negative real zeros. And we're going to do that by plugging in x and negative x. So we've plugged in x and we've plugged in negative x before to determine whether it's even or odd. So we know how to plug in x and negative x, but now it's going to tell us how many zeros there are. So for the very first one, for f of x, you don't have to do anything. All you're looking at is from your first term to your second term. It goes from positive to negative. From your second term to your third term, it goes negative to positive. And then the next one goes positive to negative. This is the only time I'm going to write that little stuff at the bottom. Okay. How many times does the sign change? So it goes from positive to negative, negative to positive, positive to negative. How many times does it change? So this is 3 sign changes. So does everybody understand that part? Okay. So what it says is the number of positive real zeros is either equal to the number of variations, that would be this, so 3, or less than that number by an even integer. So 3 or subtract 2, that's what it's telling you. What's subtract 2? 1. So there's either 3 or 1 positive zeros. It's right there. 3 minus 2 is 1. Because you go down by an even integer. So if you came out to be 5, how many possible zeros would there be? 5 minus 2 is 3 minus 2 is 1. 5, 3, or 1.
What if there's 7? Would it be
Yeah,
5?
depending on what number of sign changes you get, but it's always, no. We start with how many sign changes? What's the sign changes? Always subtract 2. Always. That never changes ever. 4, 2. Yep.
What if
exactly
there's
that.
7?
What?
So if there was 7, it'd be 5.
7, 5, 3, and 1.
That's 4.
Right? We got to do the negative one now.
It's okay. I mean,
So if we want to find the amount of negatives, we plug in a negative x. We'll get it. We got a couple times. Everywhere you see an x, you're going to plug in a negative x into the function. What is a negative cubed? Still a negative, right? So this one's not going to change. It's going to be negative x cubed. Here, what is negative x squared? Times negative 5 is negative 5x squared. 6 times negative x. And then the last number didn't change. It's just negative 4. What do you notice? there's no sign change. If there's no sign change, there would be no real negative zero. And I guess up here, I should have put 301 real positive integers. All right, so we're gonna do it again.
So it has to be positive.
3 or 1. So what that means, okay, how many solutions should we get from this function? 3. So we're either gonna have 3 real positives, or we're gonna have 1 real positive and 2 imaginary. We don't know, it just depends on how many times it crosses the x-axis, right?
Right.
But we're not gonna have what? We should not have a negative solution at all. So where is it gonna cross the x-axis? On the right side. On the right side.
Yeah.
So look,
Yes.
you tried hard.
What do you mean? What do I mean?
He was right, wasn't he?
I don't know what he said.
He said 4.
Why would it be at 4?
We don't know.
Oh, it's not data.
That's what I'm saying.
Because it's at 1. How many solutions do you have? 1 real, and where's that? Positive. Does everybody understand that? Do I have any negatives?
No.
No. Now, if I could manipulate this graph, and I can't right now, but if I could, the only other thing I would have is that it would cross the x-axis 3 times on the right, because you would have a possibility of 3 positives.
Certainly. Is the ones along the same?
Yeah.
Okay. Got something like 6. More than. Also, you have a tattoo on your arm.
Yes.
This is not needed during a recorded Zoom video, so,
You know it's bad when Hayden's your voice of reason.
Mr. Jones, that made me really like sad.
You see the concern on my face?
Yep.
It happens. All right, the next one. We're looking for sign changes. Does the sign change here? Does the sign change between these two? Yes. Does the sign change between these two? How many times does it change? 3 sign changes. So we're either gonna have 3 or how'd we get the 1? Always subtract 2. Real positives.
Why do you subtract?
Think about all the ones that we've done. Think about all the things that we've done. So every x cubed, like if I go back to these, not the 5th, not the 4th cubes, okay, cubes. When we have 1 real, what happens? 2 imaginary. Anytime you have one real, you're always gonna have 2 imaginary. So it's always gonna go down by that 1. So you can either have 3. We should have 3 real solutions. The only other possibility is having 1, because why do we have to have 2 imaginary? Plus or minus. So that's why we subtract by 2. Okay. Now we got to plug in negative x. So we're going to do -2 times negative x cubed plus 5 times negative x squared.
Wait, why are we having negative X?
Because now we got to see if we have negative zeros. Mhm. Nope, no. Next to each other, negative, 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 negative. I didn't say any sign change in there. So like on the first one, the sign changes are positive to negative. Da, 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 da. Don't, once you're done with that one, you're not looking at it anymore. Okay, so we don't care about f of x anymore. We finished with it. Is everybody good? Now we're looking at this one, just this one. What's a negative cubed? A negative times a -2 is positive 2. Negative x squared is going to be Positive times 5 is 5x squared. Negative times negative is going to make a positive, and the last number is positive 8. It's positive, 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 positive. What do you notice? No changes, no sign changes. Bless you. What does that mean? No real negatives.
So there has to be sign changes in order for it to be possible.
All right, this might be a dumb question. If that's a positive 5 times negative x, why would that?
What's negative x times negative x? You got it? Okay, no worries. What about what? So here, what is negative x cubed going to be? Negative x cubed, right? Negative x times negative x is positive x squared times negative x is negative x cubed times negative 2 is positive 2. No worries.
When you're solving,
Oh,
when you're solving, like, let's say you put in negative,
Uh-huh.
and you get like, let's say 3 changes, like perfect. Are you gonna solve it the same way as you would positive?
you're going to do the same thing. So if it were 3, it would be 3 or 1 negative, real negative 0.
Oh, wait, no.
No, it's all subtract. It's all subtract. Right.
So what happened?
Yeah, that's it. That's all it's asking. That's it. So it'll say list the number of possible zeros. That's exactly what you're gonna do. That's the directions you're looking for.
Wait, so Miss Jones, what happens if there is a sign change?
The same thing you do up here. So if there were 3 sign changes, you would have 3 or 1. Guys, shh. You would have 3 or 1 real negatives. It's the same exact thing. Sarah. Because they're all positive. Or multiplying by negatives. Yes.
I just asked this question.
I asked it to.
What's funny is first period, I told them I was gonna quit today because I was tired of answering questions 4 times in a row. And I literally said, it's not y'all, it's my 4th period.
Oh my God, that was. a good time.
You do the same thing. as you do with positive.
Yeah, do the same thing.
If there's 3 sign changes for the negative, same thing you did in positive. 3 or 1, you still subtract 2.
So you do it again?
Why would you do it again? Okay, guys, listen.
No. When you write it down the same time, you just got to, that's.
This one.
Yeah.
Yeah.
What happens if you get a change on that?
Right, that's what I said. You do the same exact thing that you did up here. So if you got 3 sign changes, but it's dealing with what? This one deals with positives. This one's dealing with negatives.
So you do it when you-
The positive X is already in there. It's the actual function.
All right, it's fine.
This one's the question that I did, because I was like. I thought it-
Yeah, and the same question that Will asked,
Well, what if there's 1 sign change?
Yeah, that's what I wanted to know.
but it's 1.
You won.
Then
But
there's
you got a
one-
-2.
If you subtract 2, it goes to a negative. Can you have a
negative.
negative
So it'd be
amount?
one real-
1 real?
So the
Uh-huh.
only-
I don't know. That was my question I was
the only
originally
subtraction
asking.
you can't
Guys, you are making this extremely complicated. You need to stop and listen. All right, I'm going to explain this one more time. Hey, everybody, 30 of you, pay attention. How many solutions can we have in either one of these? Either one? 3. Why? We could have positive solutions. We could have negative solutions. We can have imaginary solutions. Does everybody understand that? So we're trying to figure out what we have. What are the possible ones? Not the exact ones. We already know how to do the exact. I just showed you how to do that. So we're trying to figure out what are the possibilities? What could I have? So when we look at the very first one, that first function is actually your positive x. So like if you plug in a positive x, we don't have to plug it in because it's already there. Okay, so all we're doing is looking at the sign changes. Does it go from positive to negative? If you answer yes to that, we put a little check mark there. You count your check marks in the end. How many check marks did I have on this one? 3. So then the reason we subtract 2, Tiana, is why?
Oh, because, you're on.
If they're imaginary, I always have to have a negative and a positive so they go together. So that's where the 2 comes from. We have to subtract the 2. So why don't we subtract 2 from 1? So we got 3 and 1 on these. Why don't I subtract 2 from the 1?
You can't have a negative.
You can't have a negative amount of answers. I can't have a -1, +0. You see what I'm saying? Like I can't do that. So once you get to 1 or you get to 0, you can't subtract 2 anymore. But say we get 4 sign changes. So we haven't got one of those yet. If we get 4 sign changes, we could have a possibility of 4 or 2 or none. And that's okay. These are just odd and the lowest we can go is 1. Okay. Then we plug in our negative x. So I keep getting this question as well. And I've explained it and went over it. Got to pay attention, guys. When I plug in a negative, what is -1 cubed?
-1,
-1 times -2 is
-2.
positive
Oh.
2. So then we had x cubed as well. So that's why I say positive 2. Negative x times negative x is
X.
positive x times 5 is 5x squared. Yeah, everybody see that? Negative times a negative makes a positive, and then we had a +8. Do the signs change at all? That's why we wrote no sign changes. There is no possibility of having a negative answer at all. Does everybody understand that? Okay. That's it. It's just asking you those 2 questions. Is there a positive real or is there a negative real? That's it. And how many could there be? Look at upper and lower bound. We'll go over some more of them. Don't stress out. Upper and lower bound rules. Let f of x be a polynomial with real coefficients and a positive leading coefficient. So real coefficients mean we don't have any imaginary, a positive leading coefficient. So we had x squared, it's pointing up. Does everybody understand that? Positive leading coefficient. Suppose f of x is divided by x minus c. We've been doing that using synthetic division. Everybody got that? How would we put this in synthetic division? If c were a number, what would go in the backwards box? Positive c. Very good. Okay. If that c is greater than 0, which means it is positive, and each number in the last row is either a positive or 0, then c is an upper bound. The last row being the row on the bottom. So are they all positive? If they are, then it's an upper bound. If c is less than 0, that means if c is negative, and the numbers in the last row are alternately positive and negative, 0 entries count as positive or negative, then c is a lower bound for the real zeros of f. So we're going to do this. Find all the real zeros. I've told you 50,000 times how to find them. How do we start?
Plug it in the calculator.
You can plug it in the calculator, but the problem is going to be when we look at this one. 6x to the third minus 4x squared plus 3x minus 2. What do you think? It's not perfect, but it is a real one, right? Which means we can factor it. Okay, so how do we factor 4 terms? Prove it. Okay, so let's remember how to do that. When we group, we then pull out the GCF of each one. So what's in common in the first set of parentheses? What's that leave me with? Next one, what's in common in the last one? When nothing's in common, what do I write? A 1. So it's a positive 1. I don't need a negative 1 because the signs are exactly the same as what I need. You're going to write the like factors down. So 3x minus 2 is one of your factors. And then what you have left over is going to be your second factor. Now you just solve them. So I don't have to do any of that upper bound, lower bound stuff. Just solve. You're just solving. Why did I do this one this way? Why did I have to factor this one? Because it was a decimal instead of being like a whole number. So if it's a whole number, what would I do?
What do you mean? for decimal?
Doesn't cross perfect. So if it's a whole number, what do I do? Synthetic to figure out the rest of it, and then set it equal to 0 and solve it. So what's going to happen? How many solutions should I have? 3. So I see 1. So what's that mean? 2 are imaginary. What's this first one right here? How would I solve this? Do it in your head. How would I solve it? Add 2. And then divide by 3. That's all you got to do. So there's 1. What did that ask you to do? So we're done with this problem. I'm going to go ahead and find the imaginary just for you guys, just to go over it one more time. But it just asked for the real. Okay. How would I solve this? Subtract 1. And then? And you're not going to see it that way. Okay. You're going to have x equals plus or minus. I'm going to do the square root. I'm going to go ahead and plot the I. Square root of 1 over the square root of 2. They do not like square roots on the bottom. How do you get rid of the square root on the bottom? Kind of. Multiply by the bottom over itself. We talked about that when we did our conjugates and things like that. And again, this would be the answer to your problem. So read what your question is. It says real, we're done. I'm just finding the imaginary now to show you how to rationalize. All right. So then you would have plus or minus. What's the square root of 1 times the square root of 2? Square root of 2. Don't forget my I in here. And then what happens when it's square root of 2 times square root of 2? What cancels out? The square root, so you're just left with 2. But again, none of this was necessary for this problem. Make sure you read your directions in your homework, okay? If it's reals, just stop right here. What about the next one? Yeah, let's try to do grouping again. I'm gonna tell you it's gonna work.
What if there's only 3 and it didn't go straight on?
What do you mean if there's 3?
If there's like only 3, like x, 8x squared. minus-
Factor it like a normal factoring.
Where,
Or look for your whole number answer and synthetic division. So, just a normal. What'll come out of 8x cubed minus 4x squared? Lisa? What'll come out of 6x minus 3?
3.
A positive 3, Lisa? 2x minus 1. So your first factor is 2x minus 1. Your second factor is 4x squared plus 3. How would I solve the first one? Good. Add 1, divide by 2. You can do that in your head. You don't have to show me the work. What would I do on the next one to begin with? Subtract 3 and then divide by 4, which gives me a negative 3/4. What's going to happen? It's going to be imaginary. So your problem would be done right here. I'm going to show you how to solve the other one. So you said I'm gonna subtract 3, divide by 4, and I'll show you why this one's just a little bit different than the other one. When you take the square root, you can take the square to the top and the bottom. This one is a nice one because it has a perfect square on the bottom. So you're gonna have x equals plus or minus I square root 3, and then the square root of 4 is 2. So you don't have to do any of that rationalizing because the bottom cleaned itself up. All right, again, all they're looking for are the real ones, so there. All right. Applications or word problems using a polynomial model. You're designing candle making kits. Each kit contains 25 cubic inches of candle wax and a mold for making a pyramid shaped candle. You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. We're going to talk about everything in a minute. Just the important stuff. It's a pyramid with a square base. What should the dimensions of your candle mold be? If you think back to math 3, it has a point. So our volume formula is going to be 1/3 because it has a point. Big B and H. Big B stands for the area of the base. What kind of base do we have? A square base. So this one, I'm going to put side squared H so that you can understand it's a square. You could do length times width times height. It's the same thing. It is the same thing. Big B H is all you need to remember because the base area of the base is all those you should know. You should know circles and squares and rectangles. So those should be pretty easy for you. Your formulas for volume, the only one that's different is sphere. If it doesn't have a point, so it's prisms. If it doesn't have a point, cylinders, it's big BH. If it's pyramids or cones, it's 1/3 because it has that point. 2 formulas. So you're gonna need. Do what?
What's the S stand for? Oh.
For side squared, for the rectangle, like your square at the bottom.
Oh.
Yep, because they're gonna have the same side. All right, so each kit contains 25 cubic inches. So if it's already cubed, what is that one telling me? What number is that? Is that the V, the S, or the H? If it's already cubed. How do we find volume of a box? Louder. Length times width times height. How many measures are those? 3 is the cubic. Y'all understand that? That's why it's cubed. Why is area squared? Because we multiply 2 measures. Everybody understand that? So anytime you see that cubic, that's automatically your idea that that's going to be your volume. So this is your volume. So I'm going to take my formula and start plugging in. So 25. That 1/3 is not going to change. You want the height of the candle to be 2 inches less than the length of the side. 2 inches less than the length of the side. So what do we label the side? Yeah, you can do S. I'm going to do X. You can do S. It's fine. Variables don't matter to me. And remember, we're going to square it. And how do I do 2 inches less than one side? There you go. What's the hard part about this? No, solving this. What's the hard part about solving this? The fraction. How do I get rid of a fraction? Multiply. You can make it a decimal, but this one's going to be what? 0.3 repeating, right? So that's a really crappy decimal too. So I'd rather keep this one as a fraction. But I just need to get rid of the denominator. That's the problem, is the denominator. So how do I get rid of a divide 3? Multiply both sides by 3. When you do that, it just cancels out this 3. So we're going to get 75 equals x squared. Huh?
It doesn't affect the X minus.
Mm-mm. Because we're just multiplying 3 times 1/3. Which is what?
Because that's all the same
Mhm.
number.
Mhm.
Because it's multiplied.
Mhm. How do I solve this? Distribute your x squared. And then to solve our x, what do we got to get? What are the different, like for solutions? We're trying to find the answer. What are the different words for that? solution, root, 0. So what do we need to do? Get it equal to 0. Does everybody understand that? How do we get it equal to 0? So this one is really crappy. It's a subtract 75, sorry. So this is what Lillian was asking a minute ago. What if it's just 3 and it's not the 2? How do we solve this one? We've done it like 4 times today already.
Complete the square.
It's x cubed. It's x cubed. We can't complete the square.
Oh.
X squared, we can complete the square.
Wait, what's squared?
Quadratic is
No, no, no,
specifically for
synthetic.
x squared.
Complete
Synthetic,
the
by
cube.
doing what? What do we gotta find first?
The thing that goes in the back of the box. No.
Then how do we do that? You are correct. How do we do that?
It's
Beats
two.
me.
Oh my God, how have we found them all day long?
It's 2.
The
Look at it.
calculator. Good gracious, I didn't hear you say it, so thank you for being extremely quiet and then getting mad at me for not hearing you. All right, graph it. Tell me what you see. When it happens. 5. So we get, one of our solutions is 5. Do we need to find the other one?
Yes.
No, why do we not need to find the other one?
Because you have to.
They're imaginary. I can't have imaginary dimensions. That's ridiculous. So 5 is as good as it's gonna get right now. Well, when you put it in perspective,
It's worth a shot.
you can't have imaginary and candle wax.
So you just- I'm sorry, I missed it.
All right, we're gonna keep going. We're gonna keep going because you're wasting time because you still have homework. So we have 5, but it asks what? What's the question? What are the dimensions? So then how would I find my other dimension? Because this is the base, like the square. What else do I need to find? The height. How do I find the height? What do we label the height?
X minus 2,
So we do 5 minus 2 or
it would be 30.
3. All right, we're gonna do this again. This is the same question, different numbers.
Actually, it's just one. Right?
Mhm. Except, well, it's almost one different number.
More than the height.
It is, yeah, 2 inches more than the height. So each kit contains 147 cubic inches of candle wax and a mold for making pyramid. You want the height of the candle to be 2 inches more than the length of each side.
Oh, it's close.
So,
Yep.
yeah,
So what are we setting it equal to?
1/3.
147. Set that equal to now, Dylan.
1/3, and then x squared, and then x plus 2.
We have absolutely missed you. We're so glad you're back.
Yeah, we missed you a lot. when somebody else was on that question.
That is not what I said.
Yeah.
That is what Andon said.
But
What do I
it's
do?
Multiply by 3.
That is not basically what I said. No, it's not.
true.
Can you just time 147 by 3 in the head?
No, I have it on my paper.
Oh.
I
I was like about to be
can.
really impressed.
I can.
You not did it?
I can, it just took her like less than half a second.
Wow.
I'm a genius. Distribute your X and then do what?
You said it equal to 0
By
by subtracting the 440.
X a third plus 2x squared minus 441.
Probably not gonna be.
Oh, you can see it.
Let's go.
That's
No,
six.
7.
That's
7. That's
7?
One.
It's seven. It's seven.
It is,
It's
I just said, it's
Yeah,
7.
and then
That's what I said.
you said 6.
I did not.
What is your other measure?
It's 9. We can get that.
There you go.
Oh.
Oh my, y'all.
I can be. After we get our homework.
Yeah.
After we get our homework.
Spent about an hour looking at the video and writing down the notes.
Don't let Ari go.
Well, that's how long I talked, so that's good.
No, I've been waiting.
I thought you
Wait
did
another
2.5.
Mm-mm.
All right, that's enough slices.
Yeah, I can't eat all that.
I beg to differ. So this is two whole questions right here. 22, 24, 26, 28, 30. 3 questions. 42, 44, 46, not 46, 48, 50. I mean, just keep going. It's not that bad.
So that's 14, and then that's like 16 questions.
This one's 3 questions. This is your bulk.
It's
This is your
17
bulk
questions.
right there. Okay, just give me 1 second.
So just put this in here.
That's not your box.
Yeah,
Ours is over there.
Actually, it's
Oh,
the
yeah,
second
you
math
were
one.
telling me something.
Second math one.
I gotta tell you that.
Well, it said 4.
You just messed up the hall pass.
Well, I'm sorry, I was just checking. Something.
What's
What's wrong with this paper?
Guys, make sure, remember, you can use your calculators. If it asks you for rationals, what does that mean? Please use your calculator for that. If they ask you for real,
Well, that's it.
don't go with imaginary, just do the ones that cross. Everybody understand what I'm saying? Most of this is plugging into your calculator.
All
right.
All my homework.
What doing? You can take mine.
I will not.